So as you know, most of the data centers are running on either three technologies, either Zen, KVM, or vSphere. Okay, if we talk about private cloud, private cloud. Shall I explain it to you? And private cloud, public cloud.
No, I understand this private cloud.
Okay, so most of the private clouds, as you know, are working on either Zen structure, KVM structure, or vSphere structure. Okay, I have worked on KVM as well and Zen as well. Okay, and vSphere as well. So how this approach has been created for containerization? Okay, so in the earlier times, what happens is we used to create VMs, we used to create systems, and we used to run each application on one. For example, database on one VM, application on one VM, and other requirement things for other VMs. So what happens is, so this is a resource extensive work. To reduce that part, containerization concept came into the picture. Okay, and once it came into the picture, every public cloud started working on it. Okay, so everything from Google to Amazon to whatever we, even you're running whether an EC2, whether are running a VM, everything is running basically a container. Also, there's a physical VM there over there. They are creating containers and share it to you.
Okay.
Okay,
Hmm.
so wherever you go, either you're taking public cloud or private cloud or a VM, you are basically using somewhere or other way a container only. There's only one way you are using physical VM. Either you are in a hardware area where you are accessing that physical machine directly, or you're running your laptop. That is a physical one. Rest, whatever applications are running, whatever applications are serving over the internet, are running somewhere other way in the form of containers only. Okay,
Okay.
so let's go. So basically, it's an alternative to full virtualization in which application are encapsulated and container its own environment. That is already we know. Okay, is attractive. This is an attractive solution to enable developers to iterate faster. How? Because they can have their separate environment without thinking about additional cost, and they can work their own. For example, there are 10 developers, so instead of giving 10 VMs, you can have a one physical VM and have a 10 containers, and you can share it to developers so that they can work in an isolated environments and work. In the earlier times, people used to have work on one machine and give spaces to the developers, which creates problems. Okay, so that's how it just generated. And it address the benefits of the overhead associated virtual machine, allowing to higher visualization of resource definitely data centers. That is not. So yeah, I think you know this, right? How this actual virtual machine and container work, right?
Yeah.
Yeah, so I don't have to discuss explain to you. So this is nothing. This is a base layer. This is a virtual machine. Then there is a host. Then there is a hypervisor, and there are the apps are running, and each are segregated from each another. So s- okay, there is nothing I don't need to teach you. Like this is the one. So kernel is shared. You know, right? If you talk about physical machine, the kernel is shared between each and every container, right?
Hmm. Hmm.
So BFS is Docker image layer of image readable container writable. If one VM require 1 GB, then 100 require one. Like this, and how Docker is created, how Docker runs. I'll explain in the Docker. Just leave this picture because this is a different area. Right now we are discussing only containers. Okay, so yeah, Linux distribution provide kernel mechanisms such as namespace, control groups, C groups, important one, and the and the Linux feature or limits account or deletes the resource visualization collection or process, nothing else. And these are the Linux container. Again, the same. This is the root FSS, and this is the Linux kernel. Over this layer, this is same. This part is always becomes really common. Rest you can divide. So if you need Ubuntu VM, the image will be taken and the kernel will be the same, and it will have a separate containers. One will have a Ubuntu image, other with the Emacs, third with the Apache. That's how container works. Okay. So after this container, we'll discuss about Docker and Kubernetes, because these are the most famous way to use containers. Are there other ways of other way also? For example, open virtualization is another form of using containers, and Zen hypervisors is also another form. But the most famous one and the most versatile one is are the Docker, and Kubernetes is a way to manage those things. Okay.
Okay.
So if you see, so you cannot say like Docker and Kubernetes are a different thing. On the baseline, Kubernetes also working on a Docker only is just a set of UI and set of tools it is providing to maintain those Docker containers efficiently. Okay, so don't get confused with this. These are the two same. These are the only the same things only.
Okay.
Docker you already know. Okay, so I'll not is an open store platform, build, ship, running application, this and that. Okay, so system container for a Docker sign for distributed system. So if you see, this is Ubuntu. So the difference you can see from the base memory, it is taking 4 GB. That is almost same. Okay, but the difference is the image size. Here it's on 5.96 GB. Consider the fact in the single VM require minimum 6 GB of image space to get installed and give you the VM. On the other hand, you can have a Docker installed which will only take 140 MBs of image space. It will have only the necessary things which you want, not everything. So you are reusing you are basically saving the space as well as saving the memory, because every time it will read those files, it will take some memory. That's how efficient it is. Okay, and if you talk about if if rest is almost the same, the only where it will yeah, there is one more area, which is CPU area also, because everything is connected. Okay, since you have a lightweight image, your boot CPU utilization will also be minimum, so you will have a better approach to reuse those structures. Okay, same goes with the RAM as well, and same goes with the machine node. So everything is connected. Boot time is connected, in energy impact is connected, machine node is connected. So between everything. So if you talk about VMs, it will take higher resources, and if in the general I'm talking, if you talk about normal VMs, it will take higher resources, and if you take Docker, they will take lesser amount of resources. Okay,
Okay.
any doubts till now?
Nothing.
Okay, good. So so Docker Swarm, interesting one. So
Yeah.
Docker Swarm,
This
yes.
topic, I want to know more actually.
Which one? This one, Docker
Yeah.
numbers. So
Docker.
see, so this is so this is slide for only containerization. I will start. This is not a Docker. Okay, I will have a detailed Docker slides. It will on 2-3 sessions I will take for Docker. Will take each and every point inside that. How Docker works, what is Docker pull, Docker push, what is Docker registry. We'll try to go as deep as possible. Okay, so this is just an overview of these. What is Docker and what is Docker Swarm? Now, Swarm is basically additional features which gives you to create multiple Docker VMs. Okay, if you talk about, I'll tell you how Docker works. So you remember, like, we used to pull the images and create a container using a one single command, right? And consider the scenario in which you have to create a pipeline in which your application needs 10 VMs. So what you will do, you will write 10 commands separately. This is not a viable solution. What you will do, you will create a swarm and to take a configuration YML file, mention everything there. And whenever your pipeline runs, it will read those files, and Docker Swarm will help you to create 10 Docker VMs on a single go.
Mm.
Okay, that's how Docker Swarm works. I will have a detailed discussion after this in the separate slides. Okay, so don't get about this. So this is just a general view. Docker Swarm mode is a Docker solution for managing custom for multiple swarms, this and that, and a Docker container. Okay, Swarm comes in a built-in scheduler. You can schedule as well. So let's start with the virtualization. Containerization, okay, how virtualization is just another way to saying it, act of creating a virtual rather than an actual version of something, because right, when we are using containers, we are using actually a virtual part of the machines. We are not able to we are not accessing the physical machines, we are taking the virtual access to that machines to run our systems. Okay, so virtualization is operating system virtualization, hardware virtualization, para virtualization, hypervisor, and hypertoy. So hardware virtualization is a hypervisor type, and there is operating system virtualization, which is Docker, right? Hardware virtualization is different, operating system virtualization is different, and there is a para virtualization as well. Okay, so so see, traditional virtualization, you have hardware, OS, hypervisor, and you are separate virtualization containers. And in you have namespace, CS group, and CH root. Okay. And what is a container constraint? Operating system level virtualization method for running multiple isolated limits and on a single control host. This is a single control host. This one. This one. Okay. And what is a Docker? Docker, you have a Docker daemon here. What it will give, there is a Docker client. So when you send a request via Docker client, it will give you container, it will check the libraries, it will connect to this, and it will create a system like this with the help of this. Okay. And what is registry? Registry is an area where you will keep your images. Okay.
Yeah.
And there is a Docker. Whenever you just hand in, we just connected via Docker daemon. So what happens is whenever we send a request to create something, first the Docker, it will send a request to Docker daemon. Docker daemon will connect to the registry. What image that is needs to get pulled in order to run that VM. So you just connect to that registry, come back to it, create the library, send the request to the library OS connector, take the kernel with the x86 hardware, and the OS would be the same. Rest, it will build the VM containers on the top of that with the help of namespace, cgroups, and croots commands, and then it just installed it. That's how it works. Okay, so this is a Docker architecture. Okay, so uh there is a on top of that there is a Docker registry where all of your images will be there, and if you create your images, you can push those images in the Docker registry as well. It's not necessary that only the verified images will be there. If you will create your account there, you can upload your images as well. Okay, so it's a free of cost. Okay, so for creating a container, the first and foremost thing is that what image you need. So that image is in Docker. Okay, you can have a backup as well. You can upload it where or you can create a Docker file. Docker file is a set of commands in which you will have to there to create the VMs or to run the environment. Either there are two ways. In the normal Docker containers, you just run it, it will create the container, and you'll go inside, run necessary commands to create a system, create an environment. Or you can create a Docker file, it will run the VM, it will create the VM and run those commands inside that container so that your environment is ready without touching anything inside, right?
Yep.
So you have worked on Docker files or not?
Sample Docker file like by Googling.
Okay, okay, you have done by Googling. Not an issue. So you know how Dockerfile runs. Good. So there is a one more option there, which is scaling and load balancers. So these are just trying to make sure I'll explain each and everything one by one. These are just overviews. Okay, don't get confused with this.
Yeah.
So these are the load balancer. You can use load balancer to control containers. I will explain in a separate lectures. Okay, container categorization. This is Kubernetes, Docker Swarm. So yeah, there is one more thing I like to explain you. First, you can have a you can create multiple containers, and if you want to have a cluster, you can use Docker Swarm as well. There is no necessary to need Kubernetes. Kubernetes is a very good tool, but if you're not want to use, there is another tool which is Docker Swarm. On the baseline, both works the same. Both basically a cluster orchestration tool. The Kubernetes is more advanced and has a better tools. Docker Swarm is slow. I cannot say slow. It has a limited number of options, which makes it inefficient, but it is usable. People use it. So, uh, so Linux will have four major processes. Okay, boot process, kernel, root FS, and file systems. Okay, what is a boot process? Basically, starting up the laptop or computer or the VM. Okay, so bootstrap is a basically process of starting the computer. It's a short form of bootstrapping. Bootstrapping refers to the self-starting a process. A button will start with the human interface. So whenever we send, you have worked on Linux, right? You know this init command to start, stop, restart, right?
Init command to start for container you're asking?
No, on the Linux only.
No, those things I don't know.
Okay, so whenever how do you see when let's say if you are inside a container, okay, you want to reboot that container, how will you do that?
Okay, inside a container, you're logged into a container and
Uh-huh.
you want to reboot it.
Right, I want to reboot it because that is not working.
Okay, I'm not sure.
Okay, so I'll explain you. So that's why teaching you Linux also, because the base is Linux only. On top of that, we are via virtualization, we are installing Docker, and on top of that, to maintain multiple Docker image, multiple Docker containers, we are using Kubernetes. That's how it's structured. This structure works. We
Mm,
have to take one step, one step, one step. Okay.
mm,
So whether it is Windows and Linux, there is a booting structure there inside that. Okay, so so if you are using a laptop, we can use our commands to do this, but right, whenever we are using containers, we are using a virtual environment there, right?
mm,
So basically container is a part of machine only. You have given us virtual machine there. You just need to work on it and modify things. Okay, so if you want to reboot that machine, restart that machine, you can use a init commands there. So, and bootstrapping, let's come to the point. Bootstrapping is basically the process of starting the computer. So whenever even your containers are getting started, we are basically bootstrapping only. Okay, so that process is same. That's why this process is almost shared between every container. Okay, okay. So whenever you just powered on this VMs, it just load the BIOS, probe the hardware, select bootloader, load kernel, identify EF, load bootloader, determine where the kernel to boot, load kernel, instate the data structure, start init commands with the PID system. This is the init I'm talking about. There are 6 init important commands, and there will it has its own functionality, and there are some executable scripts which are the basic requirements to start the VMs or the containers, and then it will run. That's how this whole system works. Whether you are running a container, a VM, or Linux machine or Windows machine. Okay, BIOS. Mm, so basically, just it's initial test perform. So whenever you start a container, it will send a clear information to BIOS to start it. If there is error occurs, then it will give you the option. Same as the Windows. Whenever you start the VM with a click power button, it just send the signal to BIOS to start, and BIOS will have all the necessary details to start the system. MBR important one, master boot record. Master boot record will have all the details where your all storage is located. If this is corrupted, your system is corrupted. whether it is Linux, Windows, everything. Okay, so I will not read this. BIOS is there. Grub, there is a grub loader. It will have a multiple kernel images in your system. You can choose which one you want, and you can have multiple kernels as well. So let's discuss what is kernel. Kernel basically control the all the access resource. So basically it's a middleware between your hardware and your software. Whatever commands you are sending, and that's how your system will feel. Let's say you want to expose a 180 port. So you are sending a commands via software, and it will say it will communicate to kernel to expose the 80 port inside that VM. Okay, in general I'm talking. And uh, and in containers, let's say, yeah, if you talk about containers, whenever Docker is installed, then Docker will communicate these kernel to have a multiple containers inside that. So every command, which is basically it's a middleware between your hardware and the software. What on the top there is a Docker, and then at the base are the physical machine. And you want to communicate with your physical machine. How would you do that? You will take help of the kernel. So you will send those commands to the kernel, then kernel will send those responses to the hardware. Okay. So the Linux kernel has a prediction process, decompress itself in a place for this is blah blah blah. So general I have shown you. Okay. So who's created this does not matter. So what is a kernel? It's a meet both software and hardware to do anything. This is a layer of software that operates hardware at a low level. It is a portion of the operating system that always reside in the memory, facilitate interaction between hardware and software. Okay, this is how kernel will look like. Kernel is a core. This is a kernel. This is the hardware. This is a system call interface. This is a user application. So basically, we used to whenever we run to any command, we are the user application. We are send the commands to the kernel, the system call interface, and the kernel. It will connect to the hardware. That's how it works. Okay. Any questions still in the kernel?
No.
So these are the options does it does have. So this is Linux file system, so these are the file systems available. Whenever you run a container also, you will have this kind of file system. You have seen this, right? Or
Yeah,
not?
seen this.
Right? So every name is there. Where what does this is for example, etc allows system configuration. Bin have user binaries. You know this part, or shall I explain you one by one?
You can explain this one by one. I have seen these directories, but I don't know the purpose of this.
Right. Every directory has a purpose. That's why I'm explaining with this slide. So
Okay.
slash boot, and whenever you, now you know that whenever you see when you know this na, you will able to use that in a more efficient manner. So why every configuration rows in the etc, because it is designed in such a way that host specific system configuration will reside in this. Executable human binaries in the bin. Dev are the device files. Boot is the static files at the bootloader. That's why we did not touch boot part. And home is the user home directory, whatever directory we create. Library are the shared libraries and the kernel modules. We don't touch this library part. And mount point, whenever we create a mount point and attach something. Okay, this media and MNT both are same. Then OPT, application software packages. That's why we don't mix it up. Has been also there temporary files, where we create the temporary files which get auto clean automatically. Okay, and temporary files has all the permissions, so you can run it. Where variable where stands for variable logs. Okay, then root is a home directory and proc is a virtual documentation. So most of the things we used to touch etc, home, temp, and root. What else directory you have touched? Hi, hello.
Hello. Yeah.
I was asking so most of the people used to touch etc directory, home directory, temp directory, and root directory. What additional directory you have touched?
Opt MNT.
Very nice. Anything else?
No.
Nice. Have you touched where?
Yeah, I think for logs and everything.
Yes, for the
Yes,
logs only. We
I
used to
remembered.
we
Yeah.
used to go to the where.
Hmm.
So how you see you want to understand details of Docker and
How to build a Docker container, I mean, Docker file, what all things are there, and there are some user groups and all those things, right? Permissions.
build, yes, build, right.
And the all those things, and Docker, one Docker container to another Docker container, the communication between
Nice.
two containers.
Right.
I
We
mean,
they
what
both come
is,
I mean, they both communicate with each other by default, and we can have a separate rules as well to block and unblock, correct?
yeah, all those things. Uh,
And what
this
else?
docker.sock, some file is there, right?
Docker dot
Socket, something.
right, yes, right.
That I want to little bit understand more.
Okay,
And Docker creation, what all things that groups and user groups, and sometimes when we do run that this block, some security related on container, and it comes something, it is running on root user. So
right,
those things I want to understand what is that actually. This
nice.
uh, then
What else?
so Docker Hub is there, right? Like that, what all any container registry are there, and uh, so we use Docker push commands, right, to push the images to the
Correct.
container registry, right? Is there
Right.
any APIs available for that, or only commands only we have to use? All those things.
So API.
REST
So
API.
you can REST API. This is a good question. REST API. See, what people are doing is, so they are using a UI to run Docker also in the backend.
Hmm.
But in the API also, they used to hit the same command only.
Okay.
What I have seen, there is no. So what I remember, Docker is has its own structure. You cannot modify those. I'll search for the APIs, but what I know in the backend, people used to create the API on the back on the API. These commands are only running, but I'll
Hmm.
check. Good
Hmm.
question.
And
Uh,
Docker Compose.
yeah, important
And
one.
yeah, and is there any see some see when you want to push the Docker image to the container register, right? You need to
Mm,
enter the username and password.
right?
And uh, is there some mechanism to store that username and
Yes,
password
secrets.
secrets yeah,
There
locally?
is option secrets inside Docker.
So all those things, how we have to store it in a encrypted, and
In secrets, it will be secret will store the data in encrypted format only by default.
uh,
There is a
and,
version there.
and Docker Swarm, what it does.
Hmm.
Um, then storage over, and storage means it uses local file system only, right? This
So the
all this,
the kernel will be the same. There will be separate files. Okay. Separate structure will be created in the containers,
hmm,
and those files will be separated from each and every containers.
hmm,
That's how isolation works.
hmm.
Okay.
And any cron job, something can be written which has to schedule something or some cleanup process. It,
You can run cron jobs. If you talk about Docker, there are options are available in Docker swarms. We used to create that, and we used to, and in the simpler, you can run cron jobs inside Linux to run or create or delete Docker containers using a Docker file or a Docker command.
yeah, that one only I want to know, because sometimes when you pull the images, right, continuously, like for example 1.1 version, 1.2 version, and 1.3 version, like that,
Right.
versions, right? And
Hmm.
suppose that 1.1 has some security vulnerabilities, and you don't want to keep that image in that machine. So you want to clean up the whole time. Something cron job, something we can configure in
You
that.
can write a script, schedule it the cron, whatever steps you want, and whenever that time hit, it will run those steps, and whatever image you want to pull and whatever image you want to clean, it will create those tasks.
Okay. Okay, that one I'm interested. Then what else is there in Docker? Mainly that user groups you create that thing, right? That only is kind of for me. I read in
Okay.
the Google, but I mean, I never understood correctly on that.
To
Permissions.
be very honest, if I will teach you user group only if you haven't used it, you will still get confused. This is a very confusing part.
Okay, okay.
So the idea is to use it. Whatever you have read, I will read. I will teach you the same only.
Hmm. And
So
suppose in a there are two containers are there. Uh, Docker Compose, right? Using Docker Compose, we can install multiple containers, right?
right,
So can one container wait for another container to start completely? Uh,
you can take a you can create a logic over there, or you can take a sleep option there.
okay.
So what is the average time? So you have to take a general idea. What is the average time of their container? You can take a sleep
Hmm.
and then start create another container.
Okay.
So what's it will create the container, it will wait for some time, then only it will create the another container.
Hmm.
I understand let's suppose you want to install application first, database later.
Hmm.
Then you can do that.
Hmm.
Okay, fine. So I'll design my course accordingly.
Hmm.
So basics are done. Okay. So according to their documentations, okay, I will give you this one tomorrow. Okay.
Hmm. Hmm.
This is already done.
Hmm.
I will create a one PPT only and give you after that. I will try to find it today or give you tomorrow afternoon. Okay.
Hmm. Hmm.
Or then we'll focus on this.
Okay.
And the Monday we'll focus on this.
Yeah.
Okay.
Uh,
Okay. Any questions more? Any points you want to give me? You have given some good points to me.
no, I think this one.
Okay. So, so, uh, so why Docker comes into the picture? So earlier, people used to develop application via on a virtual machines only. And then suddenly there was a demand surge, due to which people were started looking for the different approach and to optimize their structures. So some went to virtualization part, some went to the containerization part, depends on the requirement. And so on the basis of these, clouds were being created and apps were being designed. So if you talk about even if you talk about in any company, even the current most of the target is to optimize their server resources by migrating their over to the cloud or reducing dependencies on the private cloud and shift to public. Okay, so this is a critical in so in the 2000 earlier 2000 there were big servers, then their step it gradually being converted into monolithic applications. And let me clear you, Docker has one dependency. You cannot run. See, earlier we used to install virtual machines and we install Applab, Apache, Tomcat, database in one servers only, and they can easily connect with each other. That is fine. But if your application has a changing behavior, which means it's changed rapidly and it continuously connects with each other, and it can shrink and expand according to the requirement, then that is not feasible to deploy. Okay, the only application which are feasible to deploy are the monolithic application. Monolithic application are those application which has a defined structure, which does not expand and close rapidly, and which does not have a uh, variable code. Okay, and which has a slow changing as well. Okay, So that so people have started creating from big server, so shifted their technology from big servers to monolithic applications, and that's how Docker came into the picture. Okay, so in the older structures, what were the issues? First, let's say the developer code. It just take a minor changes. It full and if it is needs to have just small change, not making changes in the current structure of the application. Only the minor change code update. So for that, he needs to recompile the whole structure, which is a time consuming. And application becomes a single point of failure because if something goes wrong, that server is down, your application is down. Okay, an application is difficult to scale because either you have to increase the resources, or you have to create a dummy application which will take time because people used to do it manually. And if it still take automation, booting up the server, installing it will take some time. Okay, so that's why they shifted their approach from this to microservices. They have divided their one application into smaller components so that those components can be fixed and rigid, and they can be transferred into my monolithic applications and further into Docker and Kubernetes. So these are this is a typical structure. For example, this is the code. Okay, this is being developed by Jenkins. It just send, then it sends to a developer. Developer just check the version control. It just send it over here. Then QA do the saniting. Then it will send to the sysadmin team. Then sysadmin team will develop, post it to the production. That's how it works. Okay, and there is one more reason why it is being developed because this is because usually, so developers, whenever VMs are being used, those are being in control by sysadmin team or SRE teams. So for these, they do not have the whole freedom to access because they've been being provided limited access to deploy the applications, and which sometimes creates trouble. And they have to every time they have to install a new application, install a clone in the server as well. They need to make sure that minimum application support or application package is should be there to run those applications. Okay, so this creates a headache and creates a continuous work for between sysadmin team and developers. So the, in the later words, you will see that Docker fixed this problem as well. So yeah, this is a bare metal. So this is a classical example of how things have been changed over the years. From bare metal, people have shifted to virtual, from on-premises to cloud, from Linux to Windows. This cannot be, we cannot say that people are still on Linux, and from traditional to microservice. Okay. And this I've already explained. Okay. Let's see how, see, this is a total history of Docker. So in 2004, Solaris and container zone technology was introduced. Then on the Linux containers was first introduced in 2008. We and people were started doing POCs on this till 2008 only. And then after 2003, Docker released it to open source. Then for 2026, the enterprise edition was launched, and today it's being used by everyone. Okay, so these are the total starts, how much it's being used. Okay, and so yeah, this is important. This is Mobley is a base one. There is two part, enterprise edition and community edition. Enterprise edition is a paid one, community edition is a free one. And we don't mostly, whenever our account is created is, and when we push our images, it's on community edition. So this is a typical structure: application, operating system, physical server. Okay, these are the problems: slow deployment, wars, cost, wastage of resources, difficult to split. I know it's gonna be theoretical. I'm just trying to create a structure. Okay, if you get
Okay.
bored, just let me know. Okay,
Yeah, yes, yeah.
because before going further and further, we need to have a baseline of everything. I know there must be some points which you haven't read. Okay,
Yeah.
so how hypervisor based virtualization works. There is a physical server, then there is a host operating system, and on top of that, there will be hypervisor will be installed, either Gen, KVM, or Virtuoso. These can, and this hypervisor will give you a flexibility to divide the server resources into multiple parts. Then they will have their again separate guest operating system and their applications. The kernel will be the same, but they will have to get installed. It will work as the same as virtual machine only. But in Docker, this is a different. Docker use a different approach. So better one or more physical virtual machine is equal to this and this is. What are the limitations? Right, the important one. CPU allocation. Every time you will create a VM, it will allocate a area of CPU and memory and RAM, and they will have entire guest operating system, which is storage if inefficient, cost inefficient to that. The more VMs you run, the more resources you need. Okay, what is a container? Let's come to this. So software packaging, see in containers, there will be a physical machine. On top of that, container is just like hypervisor only. The difference is your OS application system is being shared. They do not install everything in the base OS. Let's see. Whenever you install a container, for example, you need a Tomcat container. Okay, so in order, if you talk about if you go into virtualization environment and create a VM, okay, then it will install each and every dependency, each and everything related to OS. However, in container, the default one, which is to be same in every container, is not installed. Is being shared. Only the application specific dependencies will be installed by you. So which makes it more usable, more defined. And the standardized packages isolate apps from each other, share the same OS, work with all major Windows and Linux servers. Okay, so this is the difference. Container are app level construct, where VM are infrastructure level construct. Okay, basically it's a virtual construct. Here there is also physical construct. Okay, so infrastructure, host OS, then Docker, then there are here hypervisor, then there is a guest OS. Here guest OS is missing if you see. They're using the host OS only, and these binaries are automatically you can select. I think you know. So this is typically same only, the dev and then production, and then key benefits of Docker container is speed, portability, and accessibility. And these are the Docker basics. The basics of Docker image container is images are the heart of the Docker containers. Whatever is in your image will be get installed in the Docker container. Okay, then the rest is same. And container, whenever image is running, standard uniform app services container only. Engine, the software that execute the containers. See, these are the important terms: the networking, volume parts, and consider in the engine only. Basically, engine runs everything, and registry is the area where you store the images. For example, Docker container and all, and then a control panel is on manually. This developer IT operations, you know all these. Okay, so container as a service, people are using it. How they are using everything? They are pulling it from a container registry from Docker Hub itself. They just create a pull. They just pull the image. They just build the image, and they just run the application, whatever they have. And this structure row continuously. Supply chain, yes, important one. How you can use a container as a uh, in a software application lifecycle. You can use it. You just follow the structure. You have a private image registry to make sure your code is not visible to everyone. Then you have to some validations checks. Then you have to then orchestration, so that you can use Dockers as a CI/CD pipelines as well. Enterprise edition. Yeah. So Docker, these are the companies using enterprise. See, enterprise is just a paid version of the Docker. So if you need additional benefits to that, you can use enterprise. Mostly are people using a community editions. And that's it. These are the just theoretical ones. You can read it on your own. So that is Docker. This is just an overview. Any confusion, any questions related to this?
No, Vivek.
Okay. I think I have explained you this. Yes. These are the commands basically. These are the simplest commands available. First is Docker pull, is to pull the image. Here they have used Mackley Coleman catweb. Catweb is the image name. Mackley Coleman is the user in where it will find the image. Docker images will show you the all of the images which is present in your system where you are running it. And last, third command, important one, Docker run -d daemon, then -p is port. These are the port. This is the internal port. This is the external port. Then there is the name. Then there is a whatever the name of the pod. Then these are the image, and this is the latest one. If one, whenever you want to run your image, you can reuse this command. So these are the minimum requirements. Okay. Then Docker PS is the important one. Another important one. PS will show you what are the process state running related to Docker. And if you want to stop Docker, you can use stop. And if you want to remove that pod, you can remove that. If you want to remove image, you can remove by a next command. And if you want to build, you can build. And if you want to push some changes, you can push it to registry. Okay. So how many have you have run use all of these commands? Is there anything which you haven't used?
I have used all of these commands almost.
Almost all, na?
Hmm.
Okay. This is a classical example of Docker file.
Hmm.
Okay. So let me narrate you one by one. This is a base image. Alpine is the image. Okay. In the image, they have installed add and update pip and then upgrade it. Then they have copied the data from source to destination. This is the requirement text for this to this area and run. After this, they have run this and they have again copy app.py to this pod to this path and template as well, and then it exposes to 500 and run this Python command. So whenever they just run it, they just build it via this Docker file. First, a pod will be created, these commands will be run, and it will be exported on 5000.
So one thing here, uh,
Yes,
the second line, right, from the
right,
latest.
right.
one.
You said something I missed.
Yeah, that the second line, right, from
Right,
column
right,
later. So
right.
when you do that command, does it really pull that image?
It will pull from the Docker Hub.
It will pull from the Docker.
Right,
That
one. Yes,
okay.
continue.
It will pull from the Docker,
Right,
and after that, this copy scripts and all these files are there, right?
right.
Copy into that container path, right?
Right. So first and foremost thing, what will do, I'll again explain. Okay. When the second command will run, it will just pull this image
Hmm.
inside its local host. Okay.
Hmm.
After that, it run it inside it. Basically, it's run it background. It's just run that image in background.
Hmm.
Then run these command one by one, one by one.
Hmm.
And when all is done, it just expose it and it is just complete the task.
Hmm.
If you don't want to use Docker file and if you don't want to use Docker file and use it manually, what you will do, you first just pull the image, okay?
Hmm.
Then you need to go inside the container using run command,
Hmm.
right? Then you need to install these command one by one.
Hmm.
then you need to exit that container without closing it.
Okay, I have one doubt. Now, suppose there is one image,
Mm-hmm.
some test image.
Mm-hmm.
Okay. Now, in the test image, in the test image, or container image, okay, and
Mm-hmm.
in that, in one of the folder, that container in one of the folder, assume that opt, okay,
Mm-hmm.
which is part of that test image, container image, that folder.
Mm-hmm.
Now, I want to copy one file to that folder.
See,
So I
for
rebuild this image, which will copy this what you say, this file into that thing.
okay, so there are two ways you can do it. First, either you create an image, modify a current image in which all of your data is already copied. You just download that image. Okay, this is the one part. Second, whatever data is copying, it's just copying it from wherever we're running this command. It on local, it has those data. So basically, it's we are just pushing data from local to that image.
Hmm.
Okay, so if you're saying you need to copy data from other container to this container, right?
Hmm. No, 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 no. What I'm telling is, now there is one test image container is there.
Right.
Now I will build one Docker file,
Mm-hmm.
okay, and I will make the test as a base image, like for example, from
You can do that. You can do that.
right?
Right. You can do
And
that.
after that, I will copy one of my file into that image folder,
Right.
and I will do the Docker build. So
Right.
that is that okay, right? That is
R-
how, right?
See, in that case, see, so you created a test image, right?
Hmm.
Okay. Next part, next part, you're making changes in that container or not.
Yeah, I'm pushing
Okay. So when you are changing this container, you have to push that container image to the Docker Hub.
okay.
Okay. If you do not do that, on the one go, it will run.
Hmm.
But whenever you exit that console, it will forget those changes. So it is advisable whenever you're making some changes, always push those data to the image and make it a later another version, then pull that data.
Okay,
So that
you mean to say that, for example, if my base image is test,
hmm,
okay, I will write like this on Docker file, right?
hmm,
And here I will copy one text file to
hmm,
one of the directory of the container, okay,
correct.
test container, okay.
Hmm, hmm, hmm,
Now
hmm,
after this, I will this Docker file is done, then I will do Docker build. Now I will
hmm.
give the new version like test one tag.
Correct.
I will put it
Correct.
to Docker Hub, and next time when I pull the test one, right, it will
Hmm.
have the file which I have
Exactly.
copied.
Exactly. So don't have to do those things again.
Okay.
In so your first answer, your in the initial go, it will work. If you don't use Docker push, not pull, it will work. But whenever you close that console or whenever you close that system and try to run it again, all of your changes will be vanished
Okay.
because that changes was only there in that local console only.
Hmm.
So
Okay.
I'm just trying to save that data. That's the only point I'm doing.
Hmm.
The things will work, but you never know in the next console it will work or not.
Hmm. Okay.
Okay.
Hmm.
So instruction how to build a Docker image looks like very similar to native commands. These are the YML structures only. Okay.
Hmm.
And yeah, the third most important, it is important to optimize your Docker file. Okay. People, they see they have run single commands one by one. People used to done it where see the how we can optimize if this is a this these are the static changes. They are not if these are static changes and there is no dynamic changes in these files, you can directly copy those files and change the base image only. So all of these four commands should be removed
Hmm.
from 11 to 16. Okay,
11 to 16. 16.
right. If the changes are static,
Ah.
let me repeat. If the changes are static, which means if these files are need to be get copied every time a Docker file, you need new container, and these files are not getting changed. So you can already copy the file directly in the image and just push that image to the Docker Hub and just pull it from that image only. Why you need to do all these commands? That's how we can optimize. This is a one way. There are other ways also.
Hmm.
So I think you know this. We have explained it in other slides as well. Yeah.
Can you go to that previous slide? I
Okay.
glimpse only it went a bit.
So this is similar to which I have explained. So
Okay, got it.
this is the registry part, the center part. Okay. Where you can pull, create the image, just store the image. Then you have to build. If you use this image to create a multiple containers, and here in the right, if that is a success, you can deploy it.
Okay.
So installation for Docker for Mac, Docker for Windows is there, and you can do. I have a separate slide for that. Image layers are this: kernel, Alpine, Linux, Python, upgrade, copy requirement, install requirement. This is similar. This is for this reference. This slide, Docker file. Okay. Okay. Docker file system, a logical file system group. This is important one because people does not know what the theory of this Docker image file system. Logical file system are grouping a different file system, primitive branch directory files, subfolder snapshots. Each branch represents the layer of Docker image, allows image to be constructed, deconstructed as needed because there's a monolithic structure as compared to traditional virtual machines. When container is started, a writable layer is added to the top of the file system where you make all the changes. So it's a very super efficient. New container can be take on less than 1 MB of space. Container appears to be copy the original image, but it is really just a link to the original shared image. The base image is same. You are giving an on encapsulation over top of there. You can making your own changes, and only the required binaries has been installed. Rest is being shared. If someone try to change the file, a copy of the affected file is being copied up. So if two persons are working on the same image, it will work. It will work properly so that your changes are not reflected in top of that. What about data persistent? Volume allow you to specify directory to container. Exit allow the document structure. Can be used to share data between containers. Yes, it just creates its own volume. Okay. Directory persist or a container is deleted can be created via Docker file or CLI. Okay, so directory will be there after the container is deleted. Your data will be there if you're changing some data inside the container and mounting some drive. That data will be there. It's still in containers will still be get deleted. And you can create a container again to access those data. Okay. This is same slides, same slides, same slides. Okay. So this is a way to install Docker on Linux. You just curl it from the latest Docker, and you can do the manually as well. From Windows, there is a UI. There is a you can just need to go to the Docker side and just follow the steps. Yeah, there is one hypervisor needs to be enabled in the Windows 10. Otherwise, it will not get installed. Okay. So Kubernetes basically it's a project spun out by Google as open source. Next generation controller scheduler. Basically, it works on top of Docker only, and it just basically it's a UI, you can say orchestration tool, UI tool, or you can say a tool to manage a Docker more efficiently, a tool to manage a containers more efficiently. So it's a lesson from for developing a Borg and Omega and designed to ground up to loosely coupled collection of components central around deploying, maintaining, and scaling applications. So it's a Linux kernel of what does Kubernetes do? Is a Linux kernel of distributed system. It is abstract, underway hardware and nodes, provides a uniform interface of applications to be deployed, both on and consume shared pool resources. Basically, when Kubernetes was not there, even though when we haven't used the Kubernetes, when we were researching on Dockers, and this is my personal experience I'm telling you. So what happens is when for R&D purpose, Docker is fine. But when you start integrating into the production, you will face some challenges. First, regular spun up deployment. Second, how to scale those in terms of emergency. We can scale those by making some scripts and this and that. That can be done. But there is no direct tool available, and you can create multiple containers via Swarm itself, but that is not also not efficient. Even and next, networking architecture is not defined properly in Swarm. You need to understand it deep by deep, then only you can work. That's where to solve all these problems, Kubernetes came. Okay, the Kubernetes architecture, and so it has basically as a master and nodes. So master acts as the primary control panel of Kubernetes. Master are responsible for minimum and running of API servers, schedulers, clusters, and controllers. They are commonly managing, storing clusters, cloud providers, specific component, and other cluster essential services. Nodes are just a worker node, as the name suggests. They run the minimum that merges in the node itself. Task of executing workload decided by the master. Basically, master controls everything, and whatever pods you are running, it's in the node structure. Uh, any confusion, any doubts?
Nope. No.
Okay, so this is a classical structure. These are the components. I think you have heard everything about this. So let's start with the master. What consists inside the master? So master consists of system services. On top of that, there will be kubelet. Then there are container runtime. Kubelet will you will have been using kubelet when you install manually Kubernetes. Okay. Then there's a kubelet services also needs to be get installed. Then etcd, kubeI ape server, kube proxy, kube scheduler, kube control manager, and cloud control manager. And there are the cloud APIs which you can see. And then there is a kubelet. Oh my god, I just forgot your question. Apologies. So I just forgot your question which you need asked me to search. So apologies in advance.
No problem.
Today was a very hectic day for me. Okay. Uh, I will search in after this lecture only. Okay. See where we can find something. And then I'll discuss with my teammates and see if there is if someone is using anything like that.
Okay.
Uh, Okay. Then you know all these things, all the structure.
Yeah, this structure I know. In this only I had few doubts.
Yeah, I'm happy to answer that.
Okay, this cloud provider API, right? See, there
Mm,
are two controller manager in the
right,
master node, right? One is
right,
Cube and another is the cloud.
right,
I'm little bit confused between this cloud controller manager and Cube controller manager. And this cloud controller manager is attached to cloud provider API. What does that?
right. So, so do both have a different functionality that has been explained in the next slides.
Okay.
And any confusion in this node and node two?
No.
I'll come to it.
And this load balancer also, right?
Load
And
balancer. Yes, see, what happens is, see, you deployed something. See, whenever you try to run something, you want to make sure it should be higher available. How would you make that happen? By adding a load balancer between an end user and the product from the which your data is serving. So, as the name suggests, load balancer basically divides your request into equal amount of nodes so that if one goes down or if your one has a higher load, your request will still be processed. Okay. So let's say if you, I'll give you one example. Let's say you're running on a website and you want to run a website where multiple pods. Okay. If you assign all the requests to one pod and if that crash, your website is down. So it is advisable to put a load balancer between pods and this user and mention all the pods API pod and exit points to that load balancer so that then the request will not get emptied. I think am I able to explain you?
yeah, this load balancer is kind of tool.
Yeah, it's a kind of tool. There are different kinds of load balancer available. Citrix is
Okay.
a load balancer. Then there HA proxy is the famous one.
Mm.
So
Okay.
this is a separate tool and this is a separate technology.
Mm.
Okay. These are the components: Kube API server, etcd, kube controller manager, control, and kube scheduler. First, let's discuss about the API server. API server provides a forward-facing REST API interface into Kubernetes to the control panel and the data store. All clients are including nodes, users, and other applications to interact Kubernetes directly to the API server. The, as the name suggests, it's a true core of a Kubernetes. Yes, that is correct. And acting as a gatekeeper between two cluster and handling authentication, authorization, request validation, mutation. All of these stuffs is being controlled by API server. API server is a heart, you can say, because all of the APIs reside under that. All of the things can be controlled by this. Okay. EDCD as the cluster data store, consistent highly available key value stores to the persistent cluster state. Then control manager. Control manager is a primary daemon, manage all core components in the control loops. It monitors cluster state via API server and steer the cluster to the desired state. And what as compared to the cloud cluster, cloud control manager is a daemon that provides cloud providers specific knowledge to integration to control the loops of a Kubernetes. The control include nodes, routes, servers, add additional control, and handling persistent volume. I think from this is clear between kube and a control.
Yeah.
Okay, so kube scheduler, very important one, and people used to remember this because they use it very regularly. It's a verbose policy-rich engine that evaluates a workload requirement, attempt to place it in a matching resource. These requirements can be included in such as things as hardware rapid, affinity, anti-affinity, and affinity, I don't know, and other custom requirements. And node components, kubelet, kubeproxy, and container runtime. Yes, important one. Kubelet is the most important thing which we use. Act as a node agent responsible for managing the pod life cycle. You know of all these and understand YML. Any command we need to use via kubelet only to connect with it, and has a several sources like this. Then kubeproxy, all of the network rules are inside kubeproxy. Okay, and available proxy modes are user space, IP tables, or IPv6. Yeah, Kubernetes has its own network rules. Yeah, I think you'd know this, right? And we can manipulate those.
Yeah.
And there are container runtime with respect to the Kubernetes. Kubernetes is a runtime interface compatible with execution manager containers. Containers are Dockers, RKT, GitHub, and etc. etc. Additional services, Kube DNS. Yes, it can manage DNS as well. Very important tool. Okay. So what you can do, you can resolve DNS query internally in via Kubernetes only. So whatever you mention them inside those pods, those will read those DNS lines and will redirect the request accordingly. You don't need to have a separate DNS for that. You can manage inside that also. So that internal pods can communicate with the help of that DNS only with each other with that DNS only rather than pod's name. Very important concept. I think you know DNS how DNS works, right?
No, actually, these
Okay,
things I'm not aware.
okay. So, do you know what? So, in generally, do you know how DNS works?
It is kind of server, right, which resolves the IP and it redirects to the server.
You can say somewhere or somewhere something. There is a server which basically what task it does. Basically, it resolves its to domain name to the IP. Okay, there is a structure we need for. I'll not go to the detail, but yeah, the underline underline answer is this only. Okay, so then next we'll go to the heapster metrics collector for Kubernetes, which you can use for horizontal pod autoscalers, and you can use those matrices in the Kubernetes dashboard as well. The next part, which is kube dashboard, which is a UI for Kubernetes networking. 1 second. What happened? Apologies. So we were at networking. All pods can communicate with each other pods without a NAT, which is network address translations. They can communicate with each other. They have the functionality, they have the rules, and IP, whatever IP digital is assigned, that will be assigned internally, and other pods can communicate with that also. Okay. Container in the pods exist with the same network with the names. These are the important concepts. So containers are the pod in a pod exist with the same network and the namespace and share the allow IP to intra-pod communication, which means whatever namespace, how, let's say in a namespace you created 10 pods. So those 10 pods have a capability to interconnect with them and to share data packets inside that without any issue. Okay. Next, pods in a given cluster unique IP address during the lifecycle, which means they have their internal there is a term which we use to get DHCP. Yes, they have their internal DHCP, which they will assign a unique IP for that pod during that life cycle. Whenever you start a pod, it will be assigned a unique IP, and whenever you destroy it, that IP will be removed, and another time you will start, another IP will come for that. Okay. Services are given persistent cluster unique IP under so this is I've already explained. External connectivity is being handled by integrated cloud provider or external entities such as load balancers. So if you want those to communicate outside the network, you have to make some rules and you have to write some rules so that they can communicate outside. By default, they do not. Okay. Okay, so networking. And networking is Kubernetes is a plan with a container network interface, an interface between container runtime and network and plugin. These are the options which we use mostly the kube router. Rest is the other which you can use in the other Selenium, Fennel and Selenium is for Python. You can connect different languages to the Kubernetes to use their routing technologies. If you use only the Kubernetes, then you can use kube router. That is being built in by default. Okay, some important points. Cluster, you know.
One question.
Yes.
Why we need CNI?
Container network interface. So see, by default, Kubernetes, whenever you run the Kubernetes, okay, by default, it does not have any network rules being written. Okay, so those can communicate internally, but to make those some rules in so that they can communicate outside and they can communicate with some other networks. You have to write some rules. Okay, how would you do that? Either you can use Kubernetes internal structure, which is a kube router, or you can write rules via help of some other technologies and integrate them with the Kubernetes so that rules can be adjusted with that pods and pods can communicate according to your requirement. I hope I'm make you clear. Okay, let's some important concepts. Cluster. Collection of hosts aggregated their value resources on CPU RAM disk. Master, represent a collection of component making the control panel of Kubernetes. The components are responsible for cluster decisions, including both scheduling, responsive, and to cluster event. Node is a single host capable of every pod is to be created and destroyed over there. Nodes are managed by the master at the minimum run both kubelet and kube proxy. And namespace. Namespace is very important. Namespace is a logical cluster for environment, primary method of dividing a cluster into soup. So whenever we create a pods, okay, you can run different applications in one Kubernetes only with the help of namespace. Whenever you define a namespace and run the pods, those scope will be defined by that namespace only. They will not interfere with other pods. So which means You can run production names and stage environment also in one Kubernetes environment with the help of namespace logic. So that's a very important one.
It means like for each customer, we can create a separate namespace if we
Correct,
for isolation.
correct. I was all see. Uh, in the earlier times, I was using the Kubernetes as a, you can say, R&D purposes, and we were just involving this in my previous company. In my current company, 99% is everything is running on Kubernetes.
Okay.
How? With the help of this namespace.
Okay.
When I deep down the structure, I found out that there is only one physical machine. The prod is running on the Kubernetes, same Kubernetes, and the stage also. How they are differentiating? By the help of namespace. So very important concept. So this is a key pillar to run everything. So label.
Like there is isolation, right?
Right. Isolation is being controlled by a namespace on all only. And that is this Kubernetes structure is so strong and so you can say so direct that if you go for auditing purposes online, you will not find any trouble. No packet used to travel outside that namespace. It is so beautifully designed. That's why Google is using 99% of this. Okay. So label the key. So
Also, one key, I
yeah.
know one thing. Um, uh, in the names, can we move the pod from one namespace to another or
No,
something?
no,
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 right?
no, no,
Okay.
no. Namespace is a logical boundary. Anything running inside that should be stay inside that. That's how it's being written.
Okay, got it.
So whenever you want to see, if it's in R&D purposes or in the starting phase, you will not work on the namespace. You will just directly create a pod, create a deployment, and run it. Okay, you will not find namespace there. You would not need it a namespace there because you don't have a production environment there. But when you start using it, you need to bifurcate them so that another pod, whenever you create a pod in a one Kubernetes only, they can intercommunicate with each other, and you don't want that to happen. So for that only namespace is being used, and you can write rules inside that. You can write everything inside that. So label, another important concept. Key value pairs are used to be identified, described, or grouped together with a related set of objects. Label are the strict syntax available character stacks. Annotations, they contain an unidentified information for metadata. Annotations does not have a syntax limitations as label can be contain structure or unstructured data. Selectors. Selector use labels to filter the objects. Both are equals to, double equals to, not equals to the key value pair. Okay, important one. One second, let me remove this. Okay. So this is the API version. This is a classical YML file, okay, in which label annotations and selectors have been e- explained. This is a general file. This is not a dedicated file. Okay, there is a API version. Then the kind is deployment, metadata, name is Nginx, annotations, description is Nginx frontend. Whatever you want to see, mention, you can mention in annotations as the name suggests for how annotations, and label is app Nginx, tire is frontend, annotation is description. This is the difference between label and Nginx. You can label your images as this, and if you want to give a description, you can add annotations. Okay,
What difference actually? Because app engines, tire, front end, these are kind of key value pair, right?
right.
Annotation is also
Let's
key value.
let's right. If you want, let's say you want to use Nginx backend as well. So in that case, you need annotations. The label will be the same,
Okay.
and you can use another annotation for the backend. Rest will be the same. How would you differentiate when you will read it from this only?
Okay.
And then there is a replicas. The specs is replica selector, app, tier, temp. container name is image is Nginx, it's picking, and container pose is exposing to it 80 port. Another one, valid operation in not exists. So see, I think they have explained it here, but we need to run this and need to go use this on a YML files to understand it better. Okay, so don't get confused with this. I'm just giving an overview. We'll try to replicate these scenarios.
Okay.
Okay, so another one, valid operators, which is this selector section. Here, they use in, not exist, does not exist. So via this deployment annotations. Annotations is Nginx, app, tier, replica, selector, match expressions, key operation, in value in they have operator use values as Nginx, and match expressions in operator values as front end. Okay, how they are using it, I am all not able to explain because I have to use it to, because I haven't used these operators, to be very honest.
Okay.
So next is, so I'll explain with the live only. I'll not work on this demo part. Container workloads, pods. You know, there's the smallest unit to works manner with the Kubernetes. It's a compromises one container with the storage, network construct and with the namespace and C groups. Replication control, manager managing pods, replicas and their life cycle. There are scheduling, scaling, and deletion. Replica sets, next chain replica controller, support set of selectors, deployment is provides a rollback functionality in addition to the granular controller approach. So basically, you can create a deployment and you can create a replica set of that deployment, which means whatever you in a primary, you can do this, and whatever replicas you want, you can use this. So container configuration, how the deployment should be managed in addition. Template used in a general. Oh my god. I'm pausing this now.
Okay.
Okay. Reason for this. 1 second. No, I cannot pause this. Okay, let's complete this. Okay. So there is a deployment. This is a YML file. It's been written with the name annotations. Replica is 3. Mind ready second is 10 seconds. Mind ready second is means it will pause it for this, and rolling update is for maximum surge is for 5 seconds. Maximum it will check for the amount. If it is 5, then it will not do, and if it is will only do after 5, and it will only check will pause it if they are not able to do it. Then selector is labels, Nginx in front end is already there, and container is Nginx with the port exposed. Okay, I- and this is a deployment, and this is a replica set. Okay, annotation description is there. Replica is 3. Rest is same, and here this is the primary deployment, and this is a replica set. When this is getting deployed with these values, mind as ready, you can use replicas there to just deploy the existing one without using this. Okay, so basically you don't need to write everything which is being mentioned in the deployment. Once you've done the deployment, you can use those, reuse those structure and use a replica set deployment to use it in another way. Okay, to just reduce your workload. That's how it works. I'll explain it. I'll show you a demo of this, so don't get confused with this. Okay.
Yeah.
Okay. So there is a one more, two more concept. Shall I pause this right now or shall I continue? Because there is too much theory going on.
You can continue, I guess, for another some time.
Okay. So next is statefulness and daemon set. A controller tailored to manage pod that must persist in a maintained state. Pod that including hostname, network, and storage are being persistent. Next is the daemon set. which ensure all nodes may match the certain criteria to run an instance as stupid pod, ideal for cluster-wide services such as log forwarding or health monitoring. So daemon set used to mostly being used for health monitoring. Okay, and so basically, if you see here, they have mentioned the kind, and here they have mentioned the replica set. Whatever technology you want to use, you can use it in the kind. Here stateful state, here kind daemon set. If here you can kind job, cron job. So basically, this is the one part of the YML. This is not the complete YML. You can write this in the combined structure, whatever whatever you can say part of technology in the Kubernetes you want to use, you can use it. There are so many things inside that. There is a deployment, there is a replica set, there is a stateful set, there is a daemon set, then there is a job, cron jobs. For everything, you can write a you can write this is a syntax and you can write a YML, and you can add it in your generalized YML to work accordingly. Okay. Okay. I hope I make you clear about this, right?
Yeah.
Okay, so attached to the headless service in the engineering, pods are giving the unique original names using a pattern, statefulness, and creates an independent persistent volume based on the volume claims. So this is a stateful state in which Sunday's name is Nginx, image name is Nginx, app is Nginx, everything is there. Then they have mounted the path as well with the volume mounts and container, volume claim templates, metadata, read write this one. And if you come for a daemon set, bypass the default scheduler, schedule a single instance while adhering tolerance at tails. So here they use kind as a daemon set with the namespace of queue system. This is another namespace. It just bypass this and specs is cellular specs is toleration, then key is node role.kubernetes.io.master effect to the node schedule, and that is in picking the image. So basically it's just daemon set, as the name suggests. It's just making the criteria, whatever criteria will return, right, in the centralized structure. You can use those criteria using daemon set, and all the things will be used inside that. That's how it works. So they have mentioned this one. They have created this one, and now they are using in the main YML file to use it. Concept workload for the job consider ensure one or more executive will successfully terminate. It will do until some let's say you want to control a job pods execution and control the pod execution. You can do it by using job option, and cron job is, as your name suggests, used for crons. So another same way, you have to make sure the kind name is hello, completion is 10, parallelism is 2. These are the values options, and name is hello. This is a name basically. Container name, image is alpine lattice, and command is echo hello there. You can write any job, whatever. So this, whenever this will run, it will check if 10 times and run 2 times, and it will dies only after completing this condition. So number of pod execution can be controlled. This is a one way they have shown you can control your pods life cycles via this, and job can be parallelized using space parallelism. Job and pod not automatically cleaned up after the job is completed. You have to do it. Next is a cron job. Simple. You want to run cron, you can use this using kind, scheduler, name, container, image, and command. Okay. Next is service and ingress. Okay. And network. Service provides a method of exposing L4 pods network accessible resource. They are used to label selector map of groups of pods, ports, and container unique virtual IP. Ingress controller is the primary method of exposing cluster service using outside world. These are the load balancer, routers, usually offer SSL termination and name-based virtual base hosting. I, I have to pause this today.
Yeah. Okay.